Hello everyone. In this video we are going to see two numericals on electricity chapter of class 10 CBSE. So here the first question is a wire of resistivity rho is stretched to 3 times its length. What will be its new resistivity? So what they are asking, there is a wire of length L whose resistivity is rho, and we are going to stretch the particular wire as that it is of 3 times of its length. So what will be the new resistivity? This is what the question. So before answering this question, we need to know the concept of resistivity. So how this resistivity actually came? We know that resistance proportional to L by A. That means the resistance of anything is going to be depending upon the length and the area of the cross section of a particular wire. So resistance is directly proportional to the length of the wire, and the resistance is indirectly proportional to the area of a cross section of a wire. And we are going to change this proportionality to equal to, and we are introducing a constant called resistivity. So what is this resistivity? It is a constant one. So its constant means what? See, if I take a copper, it will have a constant resistivity. If I take a nichrome, it will have a constant resistivity. If I take an aluminium wire, it will have a constant resistivity. It is not going to change. Which is not going to change? This resistivity is not going to change for a particular material. If I change from copper to aluminium, then it is going to get changed because the material got changed, so the resistivity is also going to get changed for a according to the material. So for a same material, this resistivity is always going to be constant, but our resistance will depend upon the dimension of the wire. So if the length change, the resistance also will change. The area of the cross section of a wire change, then the resistance also will get changed. So hope you understood. So now can we answer for this question? So we are taking on wire of length L, and same wire we just stretched it to 3L. So material is going to be same. The wire, whatever it is made up of, the material is going to be the same. So here even the resistivity is also going to be same only. It is same, the same constant, because this resistivity is not going to change for the same material. Only it will change if the material gets changed. Okay, hope you understood, right? So we'll move to the next question. Our next question is, two wires of equal lengths, one of copper and the other of nichrome, have the same resistance. Which wire will be thicker and why? Okay, so we are taking two wires, one is copper, another one is nichrome. Okay, yes. So copper wire as well as nichrome wire both are having same length. They are equal in length. So I'm keeping L, and for nichrome also I'm keeping L. Even they have same resistance also. So I can keep here R and here R. And the question is, which wire will be thicker and why? So this is what we are going to find. So again, we are going to use the same formula, which is resistance equal to rho L by A. This is a common formula. So here, which two are constant for both? Not constant, like same for both. One is resistance, another one is the length. And our resistivity is obviously going to get changed, right? Just now I have told, according to the material, resistivity is going to change, but for that particular material, whatever the dimensions of the wire, the resistivity is going to be constant only. So here we are going to write the formula for this resistance. So R equal to rho 1. Why rho 1 I am writing? Because copper resistivity, just consider this as rho 1. Okay. And L divided by A1, because the area of the cross section, that is what we are supposed to find, whether this is thicker or this one is thicker. So this is what we are finding. So here I can keep the area of cross section as A1, and for nichrome I will take as A2. Okay. And again, coming for the nichrome, we can define the same formula with the rho 2, because it is made up of the another material which is nichrome. So the resistivity is going to be rho 2 I am considering. So rho 2 L divided by A2. Yes. So now can we compare both of these things, because both are equal to R only. So I can equate both. So while equating it, rho 1 L by A1 equal to rho 2 L by A2. So on both the side we have L common, so we can cancel L and L. So what we left with? So I want to find the ratio of the resistivity. So I am moving accordingly. Rho 1 by rho 2 equal to A1 by A2. So now what we are concluding, our area of cross section is fully depend on the resistivity of the material. So what is this rho 1? It is the resistivity of copper, and rho 2 is the resistivity of the nichrome. So first find which material will have more resistivity. Copper will have more resistivity or nichrome will have more resistivity? Obviously, nichrome will have more resistivity. Why? Because it is an alloy. Alloy will have more the resistivity. So I can say this rho 2 is having more the resistivity. Obviously, A2 is going to be more compared to A1. Since rho 2 is greater than rho 1, obviously A2 is going to be greater than A1. Then what is the meaning? A is nothing but area of a cross section, right? So the area of a cross section of the nichrome wire is going to be more than that of the copper wire. Then which is more thicker? Obviously the nichrome wire is more thicker. Hope you understood. We'll see extra problems in the next video. Thank you.